Hello everybody and welcome to another geometry lesson. Today, section 1.3. This is going to be the last section before we have a quiz, and in my personal opinion it is a little bit of a doozy. So let's work together, let's make sure that we are feeling confident about this, and let's get started. The first definition that we're going to talk about is a midpoint. So, I want you to draw the following. I want you to draw a line. I want you to draw 2 points near the arrows. We will call this A and B, as we always do, but I also want you to draw a third point that is exactly halfway between them, exactly as you can. You can guess, you can use a ruler, whatever you prefer. Either way, we know that's going to be like right around here. The point that is in between these two is called the midpoint, and I'm going to call it C. The midpoint of a segment is the point that divides the segment into two congruent pieces. So the midpoint of a segment divides the segment into two congruent, I almost said equal, congruent segments. We could say that they're equal because they're also going to be the same length, but remember, congruent is the word that we use when we describe shapes being the same thing. And since we want to say that AC and CB are the same length, we say they're congruent, and we give them congruent tick marks. Midpoints are very important. It allows us to do some math that we might not have been able to do with other points. There is something else that's special about the midpoint. We say that the midpoint bisects a segment. Bi, like bicycle or binoculars, or bifocals, means two, and sect means to cut. So when we say the word to bisect, that means to cut in half, or to cut in two. A bisector is to intersect a segment slash angle, because we're going to talk about angles that can bisect too, at its midpoint. To bisect just means to cut directly in half. So we could say here that C bisects line segment AB, because it's true, it cuts it exactly in half. What happens if we have something that bisects something else? Well, we might call that a bisector, something that cuts something else in half. So let's take that exact line again, ACB. But let's actually draw something that does bisect ACB. To bisect means to cut in half. So you could draw a line that looks like this. That line would be a bisector, or a segment bisector, because it's cutting the segment in half. But keep in mind, that's not the only way to cut something in half. I mean, lines are infinitely thin. It's very unique in that sense. So if I have a line that is about, let's say, yay long, like there, and I wanted to cut it in half, let me give these 2 points. Let's say I wanted to cut it in half. Sure, I could cut it vertically, but I could also cut it like this. Because according to the definition of a bisector, it just has to go through the midpoint. A bisector can go in any direction. There's a special type of bisector that we are going to be talking about in a little bit. But anything that intersects the segment at its midpoint here is a bisector. All right? All right. So let's see if we can use this. I'm going to be describing a figure, and I need us to start off by drawing it, because it'll give a lot more context to the situation. I always recommend drawing a picture, even if you think you know what the answer is. It always helps. Line segment AT bisects line segment MH. Okay, so we need a line segment that cuts another line segment in half. Let's say this is line segment MH. Well, AT just needs to bisect that, or cut it in half. So why don't I draw AT like this? Maybe AT has like a short end up here and a long end down here. Or it could be that these two lengths are equal. Or it could be that one is diagonal. It doesn't really matter. What does matter is this point right here. What do we call point C where they cross? We would say that C is the midpoint of MH. And it's important to show that when you bisect something, you always want to show tick marks to make sure readers know that that is a midpoint. I forgot to do so on the diagram up here, even though I said that we'd be copying it directly. So, that's going to be the diagram. Now for the easy part, which is the math. We are told that MC is 12 centimeters. So this half of the line is 12 centimeters. But we're expected to find the length of MH, the entire thing. Well, MC is supposed to be half of MH. We could say that MC equals MH divided by 2, right? If MC is 12, and since we don't know what MH is, we can call it X, we're left with just 12 equals X divided by 2. Obviously, in this case, we could multiply both sides by 2 and find that, oh, MH is equal to 24 centimeters. You could have also figured that out by recognizing that if 12 is half of the line, the full line just has to be double that, which is 24. That second way is a much quicker way of going about it, and I recommend it. Let's see if we can use that on this next example. SP bisects MO at point W. So, I'm going to draw SP. I'm going to make it diagonal this time, and I'm going to draw MO. MO is the line that's being cut in half or bisected, like so. SP is the bisector, the thing cutting it in half, and it says that it bisects it at point W, so the name of our midpoint is W. Hello, W. Of course, we want to show that these two sides are congruent because the bisector makes two congruent sides. If the entire length of MO is 40, so this entire thing here is 40 inches, what would be WO? Well, we know that WO is half of MO. WO equals MO divided by 2. We know MO is 40, we just don't know what WO is. What's 40 divided by 2? It's 20. WO is 20 inches. And again, the quicker way is just to say, if 40 inches is the whole thing, half of it is 20. Parts 3 and 4 have us identify the segment bisector and then find the length of AC. The segment bisector is whatever cuts the line segment in half. It seems like point B is where it's cut in half at, and this looks like it's a ray coming off of there. So we can say ray BD, again, rays have to go in the direction that the arrow is going, so it has to start with B and go through D, bisects line segment AC. And if AB is 1 1/2, and we know that this side is also going to be 1 1/2 because they're congruent, what's the full length of the segment? Well, it's got to be double the length of this half. 1 1/2 times 2 is 3. AC is 3. Similarly, in this diagram, I don't like how the arc was drawn here, so I apologize for that. We have another bisector, but this time it's a line. It seems like the line is line BF, and it bisects AC. A fun little tidbit is we don't actually know if AC also bisects the other figure in both of these. But with a ray and a line, it's pretty clear to see that it can't cut it in half because they're both infinite. Either way, what we do see is that half of this length is 2 3/4 inches, so the full length just has to be double that. AC is whatever 2 3/4 times 2 is. That just so happens to be 5 1/2, or 5.5. Very nice. Down here, let's see if we can do some algebra with this too. Point M is the midpoint. We have to solve for x somehow, and then find the lengths of the smaller segment, and then the whole line segment. So, how do we even start something like this? My recommendation for solving geometric questions is to ask yourself, what do we know about these segments? Well, we know that AM is congruent to MB, and we know that if two things are congruent, that must mean their lengths are the same too, right? So, actually, we have a good start here. We know that this length, 2x plus 8, has to equal 4x minus 2, because they're both a half. They're both congruent. In geometry speak, we would say that AM is equal to MB. And this is very easily solvable. This is algebra 1. We just have to start by moving all the x's over to the same side, giving us 8 equals 2x minus 2. You can add 2 to both sides to get 10 equals 2x. Then divide both sides by 2 to get x equals 5. Got our first answer. We found x. X equals 5. If x is 5, then how long is the first segment? Well, AM is just 2x plus 8. Oops, sorry. But we also know that x is just 5. So we can say that this is just 2 times 5 plus 8. Since 2 times 5 is 10, that's just going to be 18. AM equals 18 is the second piece of this puzzle. And from here, the third piece is super simple. If AM is half the line, AB is the full line. If 18 is half the line, how long is that full line? Well, the full line has to be 36. Done. I want you to pause the video and see if you can do something similar with question 6. Give it an honest try and come back to the video when you're ready. How'd you do? Hopefully we figured out that x was going to be 2 because these two line segments are the same. They're congruent, so we should set them equal to each other. From there, after finding x is 2, we set x equal to 2 on the AM side of the equation, giving us 7. If we double that measurement, we get the length of the full line, which is 14. Let's flip the page. I now want to talk about how to find the midpoint between 2 points. I'm going to give you the mathematical side of it after I show you how to do it. So, follow me for just a moment before we jump back into the mathy side of things. Let's say we have the following graph, right? And we're trying to find the exact middle point between this point here. We'll call it 3, 2, because that's where it is. And let's do, I'm trying to think of a good one to do here. Let's do this point over here. I lied, that's a terrible point to do. I apologize. Let's do this point right here. This will be much better. Let's do 1, -2, right? Some of you may even be able to see exactly where the middle of the 2 would be. But if I were to construct this line, we need to be absolutely certain that that's the middle of the 2. The easiest way to find the midpoint of a line segment is to ask yourself, what number is halfway between the x values and what number is halfway between the y values? That will actually be your midpoint. So for instance, our points are, for x's, x1 is 3, x2 is 1. What number is between 3 and 1? Well, obviously that one's going to be 2. So we know the coordinate of our midpoint, m, is going to be 2. We can do the same thing with our y variables. What's exactly halfway between 2 and -2? Well, both of them are 2 away from 0, so 0 is the middle. We just found the midpoint, and all we had to do was find the middle of the x values and the middle of the y values. If I look on the graph, this is where our midpoint is, and it looks to be the exact middle. We are given a little bit more of an extreme formula because sometimes the numbers don't work very nicely. The formula is, to find the x value of your point, add the two x values together, then divide by 2. For the y value, add the two y values together and divide by 2. This looks crazy, but all we're doing is adding the two x's and then dividing by 2, adding the two y's and then dividing by 2. Let's see if that formula works for the example points we had here. So again, the formula was add together your two x's, then divide by 2, then add together your two y's and divide by 2. Well, our x values were 3 and 1, so I'll just do 3 plus 1 over 2. And our y values were 2 and -2, so 2 plus -2 over 2. 3 plus 1 is 4. 4 divided by 2 is 2, so that's how we get the first coordinate. 2 plus -2 is 0. 0 divided by 2 is 0. We got the same answer. This formula right here that we use for finding one of the variables, one of the coordinates I should say, is finding the average. The average of anything anything is found by adding together all terms and divide by however many terms there are. So if I was asking you to find your average test score, for instance, and you got a 90, a 100, a 92.5, and a 97.5, all you need to do is add all those scores together and divide by 4, and you would get your average score, which should be 95. All this to say, the formula looks crazy, but it's really just finding the average. Before we talk about a second method, I want to actually see if we can practice this. So, I'm going to show you how to do one of these examples. Then I'm going to put up the answers for the others and want to see how well you do. So, example 1. To find the average, we've got two methods. We can either find the middle of our x's and then the middle of our y's, or we can use the formula. In this case, it's really simple to find the middle of 3 and 5. We know that that's just going to be 4. And it's super simple to find the middle of 4 and 0, too. What's halfway between 4 and 0? Well, that's 2. Just like that, in an instant, we were done. We had already solved the problem. But I'll actually show you how to use the formula with number 2 for those of you who prefer the formula method. The formula method works really well when this halfway method is difficult. If it's too hard to find the middle of two numbers, just use the formula. In fact, instead of me giving you example 2, I think the best demonstration would be to use example 6. Because it's really hard to find the middle of negative 12 and positive 16, right? But using the formula can help us. According to the formula, all I need to do is add together negative 12 and 16, and divide by 2 to get my x-coordinate. Add together 4 and 12 to get, or divide by 2 to get my y-coordinate. Negative 12 plus 16 is positive 4. Positive 4 divided by 2 is just 2. 4 plus 12 is 16. 16 divided by 2 is 8. Our midpoint is 2, 8. I want you to pause the video and see how quickly you can do these problems. I will put up the answers in a moment. So again, pause the video and see how we do. How'd we do? These are the answers to 2 through 5. Let's jump back to the notes, because there is something else. Sometimes I might not give you 2 endpoints and ask you to find the midpoint. Sometimes I might give you a midpoint and an endpoint. Ugh. So essentially what I could give you is, I could give you this, I could give you this, but I don't know where the other endpoint is, and that's a problem. However, there is a fun method that I highly recommend. You could just plug into the formula, plug the midpoint into the end of the formula, like right here, and then solve for the other pieces, but that's a lot. I recommend the bunny hop method. It sounds silly, but if it works, it's not that silly. The bunny hop method works like this. Let's take a couple of coordinates. Look at the x-coordinates, 4 and 1. What we're saying is, the endpoint, E, is at 4. The midpoint, M, is at 1, and we're trying to see where the other endpoint is. Well, according to the bunny hop method, all we need to do is see how far away the midpoint is from E. So we do a bunny hop. How far away is 4 from 1? Well, let's just 3. We subtract 3 to get to 1. The bunny hop method says that to find the other endpoint, we just repeat that process. So we just need to go minus 3 one more time. And what's 1 minus 3? It's negative 2. So this is the x value of our missing endpoint. The first coordinate of our missing endpoint is negative 2. And we can repeat this process for the y-coordinates too. The y-coordinate that we're given for the endpoint is negative 6 all the way over here. I'm going to call that E for endpoint. The midpoint is at negative 2, so it's all the way over here. I'm going to call that M for midpoint. I apologize, the diagram's getting a little clustered. All I need to do is bunny hop our way to the other endpoint. So how far away is M, our blue midpoint, from E, our blue endpoint? It's just plus 4 away. So to find the other endpoint, we just have to bunny hop 4 forward. And what's 4 more than negative 2? Positive 2. Our other endpoint has a y value of positive 2. The bunny hop method is super quick. You just got to do it in 2 steps. Bunny hop your x's, bunny hop your y's. Notice that when you start at a number and go to the left, so this bunny hop went from here to the left, you are decreasing. That number is going to become more negative the further you go. If you start at a number and go to the right, like we did for our endpoint here, you are increasing. Your number is going to be more positive, or sometimes bigger. That is the basis of the bunny hop method. Let's practice it on the next page. I've given you some number lines if you want to write down these bunny hops, but eventually the goal is to be able to do these bunny hops in your head. So, let's begin. 7, I'm going to warn you, is very tough with the bunny hop method. Oh, you know what? Let's do it anyways. Let's do the bunny hop method with this one anyways. Let's start with the x's. Negative 7 and negative 2. According to the bunny hop method, we have to first figure out how far away negative 7 is from negative 2. To go from negative 7 to negative 2, that's the end point to the midpoint, be plus 5. So, if we plus 5 again, what's our new endpoint going to be at? Our new endpoint is going to be at 3. So, the x-coordinate of this is going to be 3 comma something. You don't need to draw the diagram, I'm just doing it to show my thinking. Similarly, if we start at 6, but then go down to 4 for the y-coordinates, again, we found that because the endpoint's at 6, the midpoint's at 4, all we need to do is bunny hop our way over. To go from 6 to 4 is minus 2, so we just have to go minus 2 again to get to our other endpoint. 4 minus 2 is just 2. There we go. So, we have the point 3 comma 2. Once again, I'd like you to try practicing this on your own, so pause the video and see how you do. How'd you do? 214, negative 9, 8, and 29, 2. This is a huge bunny hop of 20 to get from negative 11 to 9. But we got there. Let's flip the page. We are so close to being done, but this is going to be the toughest part. The toughest part of this section is going to be finding the distance between 2 points. The formula is rough, but there's a reason for it being so rough. Everybody, we have to find how far away 2 points are. It's not quite as easy as finding the midpoint, though. We need to find an exact measurement, and a lot of times, these points are not actually easy to measure. Some of them are very easy to measure, though. Like, if we went from A to B, we literally just need to count the grid lines. 1, 2, 3, 4, 5. That's super easy and something we've definitely done before. That's just 5 units. And same thing if we went vertically. To go from B to C, we could just count the units. 1, 2, 3, 4, 5, 6, 7. The distance between B and C is 7. You could also use that distance formula that we had learned from last unit to do these regular vertical lines. But how on earth are we meant to find the distance between A and C? It's a diagonal. Well, we did learn a method back in middle school. It's just that we're probably out of practice with it. The method that we can use here is the Pythagorean theorem. The Pythagorean theorem is something that's going to come up time and time again for us, but as a reminder, here it is. A squared plus B squared equals C squared. Simple as that. Now, we can dissect this a bit if we want to. I kind of don't want to for this. I kind of just want to see if we can solve it. Remember that C is the length of your hypotenuse, or your longest segment, which is definitely the diagonal here. Also remember, the Pythagorean theorem only works if your triangle, is a right triangle. In this case, it makes a 90-degree angle. Those two lines are perpendicular. So, let's take the lengths and see if we can solve. 5 squared plus 7 squared is supposed to be this mystical C squared. Well, we know that 5 squared is 25. We know that 7 squared is 49, so that should equal C squared. But how do we get C all by itself? Well, after we add together 25 and 49 to get 74, we learned that to undo a square, we can just square root both sides. That's the inverse operation of squaring. So we just need to square root both of them. In Algebra 2, we'll talk about how to find this and simplify this square root a little bit easier. But for now, this is something that I don't expect you to do. Instead, I expect you to find the length of this line C that we're calling it, by just doing it in your calculator. So the measurement of line C, or AC if you want to use the points, is going to be the square root of 74. Just to clarify, the square root button is this blue symbol right above the square. To access the blue, you just have to click second and then the button. So the square root of 74 is 8.602325 blah blah blah. But I'm not going to write that whole number. Instead of writing C equals a number, because I would have to write it out forever, I'm actually going to write C is approximately that number. That'll let us round up or down. And 8.60, 2 decimal places, is pretty standard. So 8.60 units is how far away A and C are. What I want to do is I want to take this idea and turn it into a formula. So, keeping this in mind, keep in mind this idea of squaring some things and then square rooting them, I want to work out a formula that can help here. So let's see if we can figure it out. we start off with our simple Pythagorean theorem. A squared plus b squared equals c squared. And remember, our goal is to find c squared, the distance of a diagonal line. We don't care about how to find the length of a straight line. We can count that out. Let's start by getting c all by itself. To get c all by itself, we got to get rid of the square by square rooting both sides. So we've got this big square root on both sides, and what we're left with is the square root of a squared plus b squared equals just the letter c. Okay, good so far. In this particular image, line segment C is actually line segment AB using points. We'll be talking about that and relabeling that in just a second. But keep in mind that that's what we're talking about, is this length here. Now, in order to figure this out, we would need to find A and B, these two straight lines, right? Well, the interesting thing is, it's pretty simple. If A is at x1 and B is at x2, point A and point B, I should say, then the length of point A is just x2 minus x1. That's the distance formula we learned in section 1.2. It's just the absolute value of x2 minus x1. So instead of calling this segment A, I'm going to call it x2 minus x1, because whatever these numbers are, their difference is the length of that segment. So I'm going to actually say that this is the square root of, instead of a squared, I'm going to start calling it x2 minus x1 squared. And we can do a similar thing for b. The length of this segment b is just the distance between y1 down here at the bottom, the y value, and y2, the y value up here on point B. This distance is just the difference between y2 and y1. In other words, it's just y2 minus y1. Very nice. And like we said, this is going to equal line segment AB, which is what we're using for C. Believe it or not, this crazy looking formula is something that we can use. Now you might say, Mr. Strager, what happened to the absolute value? I remember back in section 1.2, right over here, you talked a lot about the absolute value. See, I remember it. You're absolutely right. But there's a fun trick that we can do in math. When making formulas, anytime you square something, it's always going to become a positive number anyways, assuming you're talking about real numbers. So, no matter what, if this is positive or negative, it's just going to turn positive when I square it. That's basically absolute valuing, right? Squaring something is like a cheaty way to get the absolute value. We have ourselves a formula. It's a long formula, but a formula nonetheless. The distance between any 2 points is the square root of, parentheses, x2 minus x1 squared, plus, parentheses, y2 minus y1 squared. Let's see if we can put it into practice. Over here, I'm trying to find the length of line segment AB. This one right here. So, let's start by taking our x values and plugging them into this equation. The distance is equal to the square root of the x values subtracted from each other. The first x value I see is a, so I'm going to call that, I'm going to call that x2. It doesn't really matter which one is x2 and x1. The second x value I see is negative 4. So negative 1 minus negative 4 squared. Let's see if we can do the same thing with the y values. The y values are also pretty easy to find. They're 1 and 3. So it's 1 minus 3 squared. Again, the order for these does not matter because we're just going to square it in the end. We don't care if it's positive or negative. Negative 1 minus negative 4 is going to give us negative 5. So this becomes negative 5 squared. I'm so sorry, everybody. I made a gaffe. Negative 1 plus negative 4 would be negative 5. Negative 1 minus negative 4 is positive 3. That was silly of me. So this is just 3 squared plus 1 minus 3 is just negative 2. See, I got that one right. Negative 2 squared. The problem becomes more simple. Now it's just figuring out what 3 squared is, figuring out what negative 2 squared is, adding them together and square rooting them. 3 squared is just 9, and negative 2 squared is just positive 4. So this is like the square root of whatever 9 plus 4 is. We happen to note the square root of 9 plus 4 is the same as the square root of 13. 9 plus 4 is 13. And this is the part where we get to use our calculators. So once again, second square root button, 13, enter. Line segment AB is approximately 3.61 units long. 3.61 units. Fantastic. I want you to see if you can do this with the next two. It is a very long process because the formula is very long. But none of the individual steps are hard. It's just using the formula is a little bit tricky. Pause the video here and see if you can find the lengths of line segments AC here and AD here. Pause now. How'd you do? Did you find out that AB and AD are actually the same length of 3.61? Yeah, the diagram doesn't look like it, but this is a very important piece to keep in mind. Diagrams can be deceiving. A lot of times, if you're freehanding a diagram, you won't be point accurate. But the math doesn't lie. We have found all of these distances. Thank you so much, everybody. That concludes our notes for today. Have a fantastic rest of your day.